Good morning, everyone. Good morning. Can you guys hear me? Let me know in the chat. Can you guys hear me? Joseph, Ekta, I can see you guys. Thank you for confirming, Ekta and Arad. So, Ekta, you left last class little earlier because I was asking at the end you were there or not. It looks like you left the class earlier little. Very good morning, Joseph. Very good morning, Arad. How you guys are doing? Okay. That's fine. That's fine. You can watch the recording. And I think we have covered, I think, the stream, like the frame question. Yes, the frame question was little interesting, so you should watch the recording. And then the last one was easy, so you can do it. And then if you stuck somewhere, you can watch it again. Yeah, I also actually woke up little late, so let's do that. Let's start our class and let's understand today's some of the advanced problem with stack. And I have seen that some problem we have already covered it, so we'll just revise them. And there are some problems, some new problems as well also there, so we'll see them as well. Very good morning, Hariharan. I'm very happy you guys joined it again. We've just met last night, and now we are again joining. So very happy. I know some might be having some classes. So sorry, classes. I'm saying some might be having jobs like Nilanjan. I remember he goes on Saturday morning, and I think Relable was telling they were giving me two time interval for taking a class. So there one 10 to 1, and second was at the same time at the evening 8 to 11. So I have chosen this one 10 to 1 because after this class I can also have the whole day and tomorrow's as well, and you guys can also have the whole day for today as well as you can do the preparation on next day as well. So that's why I taken this one. Otherwise, like whole day goes like that to think about the class and having the content. So that's why I thought morning is fine. Okay, so before starting our today's class, you guys want to talk about anything which you guys have not understand from last class? Any specific place? I know it's little early because after the class, you guys just simply slept and then coming joining it again here. Yeah, I know that. I know that. But still, if you guys face anywhere problem, I can go through the code or anything like that. Otherwise, we can start today's class. And I think on Monday, when we will have the next class, then I think, yeah, it still remains in the head, correct. In Monday, actually, when you will, like when we will again connect, on that time, you guys can ask and we can answer it. Okay? Yeah. So let's start today's class. Okay. I think let's wait for 3 more minutes so other people can also join. I can see number of people who has joined. It's less than 10. So let's wait for some more minutes and then we will start. Okay. So before going into that, good morning, Suraj. Yes. So before going to that, so just revise, guys, about the stack because today's topic is going to be stack, right? So just like bring all the stack properties into your, the cache memory because whenever we do not revise, all those things goes into our back memories. So let's bring all the things into the front. So let's start with stack. So the properties or the feature which stack provides you that the feature was LIFO or FILO. The two words was there. The what do we say? Acronyms were there, which was LIFO and FILO, which was last in first out, or we also say that first in last out. Correct? Like we have taken the example of chairs in the marriage hall, or the plates in the same marriage hall when we have the plates in the food table. So those also put it into one order. So the last plate which has been put into the piles of these plates, you will first pick that plate, and then the first plate who has been put it in the table, you will take it at the last point. Correct? And this time, actually, the marriage season is all marriage. The what do you say? Uh, Time is also going on, so a lot of marriages are happening in my friends as well. I'm also like that's why I'm also planning to in the I'm coming to Delhi, so that's because of that reason. So yeah, so just I was just thought to tell you. So yeah, coming back to the example that so that was the stack, right? When we have these so many plates, and when we want to pick anyone, oh, not mine, not mine. I'm not talking about mine. I'm talking about my friends. Hariharan, okay? Yeah. I'm saying like, this marriage season is going on. A lot of people are marrying, right? So that's what Salag, in Hindi we say that Salag has started. That's what I was just giving you the reference. So yeah, so coming back to our example that in stack we have, I was just giving you the example of the plates which we have in our marriage hall, right? So the purpose of the stack is lot of places we have seen that whoever is entered first, that has to execute at last. That has to execute at the last. You can see the real-time example of the stack is JavaScript engine, right? It also uses one call stack. So whatever function you are putting, like and many like at the same time you can put multiple functions in the stack. So whoever has entered in whatever way, that function continuously get execute. So there are multiple examples on many places we have seen that sometimes we need to follow these patterns where whoever has entered last has to get out first. A lot of places we have seen that. So that's where the stack could definitely help us to solve the problems. Correct. And the next thing which we talk about in the stack, it was some of the operations which a stack has, right? So the common operations are push and pop. In push, we simply insert the element, and in pop, we simply delete the element. Correct. And the next thing we talk about, how can we implement the stack, right? So there was two ways we can implement a stack. One was through the arrays, and second was through the linked list. Correct. So and we have seen that because we have already covered a lot of classes. So you guys have seen that when we were trying to implement our stack or queue with the help of linked list, you guys have observed that the time complexity was constant there. We can do push and pop operation in the constant time. Am I right, guys? You guys have seen it, right? So yes, so we have already seen that thing. So that was one thing. So that's why people use somewhere stack when we know that the pattern which we need to follow, which is the pattern is we have to insert it from the back, and the whatever the top element we need to take it out. When you see these type of patterns, so we simply go with the stack. Okay, so next thing after that, I remember we have talked about the in stack only we talked about the next greater element or next greater element, next smaller element, and previous greater element and previous smaller element. The four questions you guys know about the pattern which we have discussed about, which was solving a lot of problems like the uh, stock span problem and temperature. There was one temperature problem was also there, and then we have I think histogram was there. Yes, histogram was there, and then I think finding out the rectangle, that was also the extended part of histogram only. Yeah, the max rectangle. We also have today's the same problem, max rectangle. So we will discuss it in the slides. We have the similar problem of max rectangle. Correct. And so yeah, I think that's all. And apart from that, we have discussed I think some other problems as well where stack was helping us. Correct. So today we are going to continue from there only. We are going to solve some problems which has been given to us. And yeah, that's also right. Aradha has told queue using stack or stack using queue. That also we have solved the problem, right? The collision one, yes, I remember there was multiple planets, and we have the weight and directions of them. Then they are moving into the if they are moving into a different direction, there was a possibility for collision. correct? If two opposites are like minus minus are running, there might be chances they won't be collide. So that was one of the questions which we have solved. So yeah, I think a lot of interesting questions was there in the stack as well, right? So I believe that's how when you will so after today's class, I think we are not going to discuss the stack again after today's class, because this will be the last problem which we are going to discuss about the stack, correct? But you guys have seen it lot of places after solving problem in stack. You guys might have seen it while solving the queues problem, while solving the heap problem, or while solving any other trees problem. We might have used stack many places, because in JavaScript our arrays work like a stack only, right? In the array we can simply push always in the stack, always in the array also we push it from the back, and array also provides us the same method name as pop as well, which stack has. So with the help of pop, we just simply delete the last element from the array, correct guys? So that's why you guys might have observed or might have seen that a lot of places we have done it, like in the heap also. In the heap, the last problem which we have solved, a lot of places we were doing the stack dot pop, right? Or stack dot push, correct? When we were trying to push any element, we were in one way we were using the stack only, correct? So you guys have seen the internally stack or the queue, a lot of places we can use it, correct? So to solving the complex and bigger problems as well. So I think yeah, that's all about the stack, guys. I think we can talk in the theoretically about it, and and we also know that in the JavaScript how to implement a stack with the help of arrays or with the help of linked list. And JavaScript, and by the way, we do not need to implement a stack, because as we know that JavaScript array are by default, they behave like a stack, so no need to implement them. So yeah, guys, I think that's all we can talk about the stack in our theory. Do you guys have anything to add more here about the stack? Arrays also behave as queue. Totally right. Arrays also behave as a queue, because in array we have a method called front, right? Like sorry, in the queue we have a you know enqueue and dequeue. There are two methods, and enqueues work same as the push. Enqueue works same as a push, and there was dequeue. Dequeue means take the top element out of it. So I think for that we have the shift method, right? We have the shift method which deletes the first element from the array. So definitely our array also work as a queue in JavaScript, not everywhere, guys. Every time, do not make your, like when somebody was asking, you do not say that arrays can behave as a queue, array can behave as a stack. You are only going to tell this in the context of JavaScript, not everywhere, not in C, not in other languages. Only in JavaScript you can say that JavaScript, it would be better you use like this: JavaScript arrays can behave as a queue, can behave as a stack. Okay, guys, everyone will remember this thing about stack when they are talking about with the context of JavaScript. Yeah. Anything else you guys want to add into this stack? Because these are the last classes. We are doing the revision. So it would be good if we could collaborate together into this. If I miss anything here in the stack, the time complexity, and we know that O of 1 is there, going to be there, and space complexity, the size of array. So it would be whatever element we are adding. So it would be O of n, correct? And if we want to search any element in a stack, so definitely it is going to take the O of n, the worst time complexity, because we might be finding it at the last place in a stack. So O of n for finding out an element. So you know that now you can relate. That's why we use the hash. Hash was there. That's why we were reducing the time complexity of searching part. That's why we have come with the idea of heap table or object and map. you know at the end we were using the arrays, but for finding out any element we were using the hash values. You guys can relate it what I told it right now, the hash part or the heap or the sorry not the heap, the object and map, how they are relating with the arrays. Correct. Push will be O of 1, right? Yes, push and pop both will be O of 1. If we are, I have shown you that also, right? If we were using a linked list while implementing our stack, at that time it would be O of 1. Correct. Sir, for stack question for interviews, I think we have covered some very standard questions, right? Yes. So see, stack or like the max histogram, and there is one problem called rainwater trapping, which we are also going to discuss this today. These are some of the problems which people ask in the bigger interviews. Correct. So I think yes, we have definitely solved the standard problems or also the edge cases problems. Like I remember the stock span, next greater element. These are the edge cases problem which we solve in Stack. So till now, whatever they have asked, we have definitely covered it. So now it just we need to practice it more. Yeah. For Stack using Q, pop is O of n. For stack using Q. Yes, there was when we were implementing stack using Q or Q using stack. So in one of the operations, we need to do O of n. In one of the operation, even it could be insert or it could be delete. Anywhere, one of the operation would be O of n. That's totally right. Push it O of 1. Yeah. Theoretical questions, I would believe theoretical question could be related to time complexity and and yeah, the pattern wise, like last in first out on first in last out, they can give you some pattern, like they can give you some use case, right? And they will ask you which data structure would fulfill your solution or which data structure would be best there. So you need to read the use case and you need to think about, is it going to take the like the stack properties, like the last one will go and first one go out. If that is coming into that category, you will consider that stack could be the best to use here. These type of questions could come here into theoretical part. Otherwise, I think the mostly questions should come here on the programs which we are already solving it. Yeah, I don't think why I'm putting the. What about now, guys? Can you hear me? Oh, great. I don't know what happened. I just put the charger here. It happens. Okay. Sometimes we do not know what's happening inside the computer. So let's say, let me share my screen and let's look into the first question. I think the first question we have already covered it, but yeah, still we'll see that. Okay, you guys are able to see my screen? You guys are able to see your comments? Yes? Okay. So let's now jump into the first question of our today's. Let me open the OneNote also. Ah, it's already open. Okay. So the first question, guys, let me ask you guys if you remember this question or not. So the first question is, they have been given us one string, which is determining or denoting a positive numbers, and they have also given us one integer k. You need to find the minimum possible digits that can be formed after removing k digits from the string. Correct. So they have given us this string 8973132, 8973132, and they are saying us, they're asking us, you have to remove 5 digits from here. And after removing 5 digits, what could be the minimum possible number we can generate from here? So, like, let me write it here. I think you guys remember now this question, we have already done it, but let me still show you. 8973132, and the value of k is 5. So we need to remove the 5 digit out of this number, or they are treating it as a string, by the way. They are saying it is a string. Okay, so they are saying you need to you need to remove the 5 characters, I would say, or numbers or digits. Yeah, let's consider it as a digits. So you have to remove the 5 digits from here, and after removing the 5 digits, what would be the minimum number? So right, so always let's remove, always when we want to reduce our number, so see, just a simple example. When we have 45 and 34, you know that which one is minimum here? 34. So how we are saying it's minimum? Because it's the first digit of this number is smaller. So that means whenever we want to make a smaller number, always you know, I'm talking about the first digit from the left side, not from the right side, because somebody can also say to me that the first digit can also from the right side. So no, I'm saying about the from the left side, we need to always reduce our digits. Reduce our digits. So if I try to remove, let's see, if I can remove this 5 digits, the state 5 digits, so I will be getting 32. Correct? I would be getting 32. Now, this is the final answer. Actually, this is the answer 32 will get. But let's think about, is there any other digits we can remove which could reduce our answer? Which can reduce our answer. Oh, sorry, this could be one is if we do the state. But let's see if there is any other digits, any other 5 digits, if we remove, then we can get the answer. So let's see. Uh, by the way, one let me check one more thing. Is they are saying like it should be ordered or anything like that? No, they're not saying anything like that. It should be ordered. So I think if we remove 8, 9, 7, 3, and also this one, this three also. So I think 1, 3 will be the next number, and 1, 2 is also there. So I think yeah, this one is the smaller, right? Any other number you can think about here which can make our string or number smaller? Or you cannot like shift. You cannot write like 2, 1. You cannot write like this 2, 1 like this. You can't do that. In whatever order these numbers are coming, you need to take into the answer in that order only. So that's why you can see 1, 2 is here, not 2, 1. I'm not considering 2, 1 as my answer. Okay, so I think yes, answer is here 1, 2, because that's the minimum. Because that's the minimum. So guys, do you guys remember any of this question which you guys have done? Which you guys have done in our class when we were having? Anyone remember? Ekta says yes. What about others? Arad also says. Parag also says. Okay. Great. I think you guys remember it. So if you guys have remembered it, so removing previous and next element. Removing previous and next element. Which is greater? Yeah, which is greater? Correct, 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 correct. Yes, Joseph has remembered the logic also. That's totally correct. So yes, guys, that's what. So see, guys, what we are going to do, we are first going to let's draw the graph for that. That's how we started our problem, right? So let's draw the graph for them. So let's consider this is our 8, right? This is the place where we have 8. Then we went for 9. Then we went for 7. I can consider 7 would be here, little bit down, right, guys? There is 7. Then 3, little bit more down. I can consider this is our 3, right? And then we can go from here to 1, which is little bit more lesser, right? And then we are going little bit up to the 3, right? And then from 3, we are going little bit less to the 2. That's how our numbers are representing, correct? If we just draw something like here, correct? This is how our number will represent. So guys, we need to find out the maximum number, right? We need to find out the maximum number. That's how we started. See, if the kth value is 2, just consider the value of k is 2. So we only have to remove 2 numbers from here. We only have to remove 2 numbers from here. And as I told you, always the lesser number would be when you will getting the smaller number in your like in your when you have a smaller number at the first index, that would be like let's just consider first you got 4, and then you got 3, so you have to remove the 4. Because 4, if you will consider 4 as your answer, it will never give you the greater number. So that's what we are also going to do here, guys. We will start traversing this array, and once we got a dip or lesser number, we are going to remove the previous number. That's what you can see. Like if we have 5, or let's say if we have 2 here, if we have 2 4, and then we have 44, and then we have 3, so it would be better to remove 4, because you can see, like just consider we have 3 numbers, 2 comma 4 comma 3, right? So it would be better to have 24 or 23. Which one is smaller here, 24 or 23? So 23 is smaller. So that's why once you got a little dip or a smaller number after a greater, you need to remove the greater one. And that's what we are also going to do here. So see, first we will in stack, and how we'll do that? We will do it with the help of a stack. So we'll take a stack here. Correct. We'll insert our 8. Because this is the first element, we can't do anything. The first element directly insert into the stack. Now when we traverse our next index in our array, we'll check first, is the value of k is still positive, because after that only we can remove it. So yes, the value of k is positive. We still need to remove 2 elements. So what I'm going to do, I'm going to push. I'm first going to check the next element. Is it smaller than the stack top? No, 9 is greater. So I told you, if we are having greater numbers, like first 2 is inserted, if we have greater number, we won't do anything. Just push it in the stack. Same we are going to do here. Once we get the greater number, push it in the stack. Correct? So we have pushed the 9 here. Now our stack top is 9. Now we got the third index. Again we check. The value of k is positive. Yes, the value of k is positive. Again we got a 7, the third index. This one, which was smaller, which was smaller than the stack top. So now there is a chance, right? Now there is a chance. If we remove the previous element, so see, till now, if we leave it like that, so our number will look like 89. If we remove 9 and put 7, so 87 becomes smaller. Correct, guys? So that's why we are going to remove the older number. So once we got 7, we'll remove it. We'll remove this 9 from here, and we'll reduce the k value as well, because we have removed one element. So now kth value is also 1. Again we'll check. Again we'll check for the 7. Is it greater? Is it the smaller than, or yeah? Is it the smaller than the current stack top? Yes, it is still, and kth value is still positive. Kth value is still positive. So what I'm going to do? I'm also going to remove 8 as well. Correct, guys? I'm also going to remove 8, because you can see, if I remove, just visualize it. If I remove this one, 8 comma 9, so now the connection is like this, 8 comma 7. Again you can see the dip is here, so we need to remove 8 as well, the previous greater element. So that's why we are going to remove 8 as well. And now the value of k is also become 0. Value of k also becomes 0. So now, guys, we have removed 2 greater elements from here. So our answer, if the k value is 2, our answer would be 73132. That would be our answer if we just need to remove the 2 elements. And that's what, after that, you can just simply insert all the elements, 7, 3, and then 1, then 3 and 2, and just return your array from here. That would be your answer. Correct? Understood, guys? That's what we did. Right? Now, yes, everyone remember. Now let's consider some edge cases. That was the solution actually. Now there were some edge cases, right? So the first edge case is this. First edge case is this. If we are not getting any greater element, because we are looking in the stack for greater element, but if we are not getting any greater element, so like if I want to, again, the value of k is 2, but somehow I'm not getting any greater element. So it means our input is like this, 5, 4, 3, 2, 1. No, wait. We are getting a smaller element. Oh, no. This will not be the input. Our input would be opposite of it. 1, 2, 3, 4, 5. Correct? Because we were looking for the greater element. But now you can see, once we inserted 1, the stack top is 1, like this will look like this. 1 is here, then 2 is here, then 3 is here, then 4 is here, then 5 is here. If this is the case, guys, correct? So in this case, what we were looking? We were looking, when we are inserting the next element, we should be looking for the stack top. And stack top, if stack top is greater, we need to remove that one. But in this case, it will not happen. Correct, guys? So we will push all the elements 1, 2, 3, 4, 5. Correct. And next, once, because we do not have anything, so in this scenario, we just need to at the end we just need to remove these from our stack, just those element till we just need to pop those element till our k becomes 0. Till our k becomes 0. This is the first edge case when we do not have any dip. You can see we are first in the first case as a regular solution, we were looking for the dip, but in this case we do not find any dip. So this while loop will fully execute, but it will not remove anything from the stack. So at those scenarios, when k is equal to 2, so you just need to simply after completing this while loop, you just need to run one more while loop and reduce your k value and remove the because in this scenario k value is 2. So you can just remove the top two maximum element from here, and your output would be 1, 2, 3. This is the minimum element. This is the first edge case when we do not have any dip. So at the end, whatever element are present in the stack, you just need to run pop operation till the kth value becomes 0, and whatever you find it at the end, that would be your answer. That is the first edge case. Did you guys understood this edge case? No, Rad. That one is dipping. That one is dipping. Your example is dipping. After 8, 7 is coming. It means you have to remove 8. After 7, 6 is coming. You need to remove 7. I was talking about the different one when we do not have any dip. Correct. While k is equal to 0, stack pop and yeah, that one. Correct. Now there is some more edge case when we have 0. When we have 0 like this. Let's take example like. I have example. Let's just think about example. When we have zeros, right? So let's think about like this: 1, 2, 0, 4, 3. Correct? 1, 2, 0, 4, 3. If we have, okay, 1 minute. Let me think. Oh, by the way, I have examples. So we will take that example. No? Otherwise, we will rearrange the example or anything. Where is that question? Min digit, right? Yeah. Okay, 1, 0. Okay, that's then I think this example is better, which I have there. Okay, so now let's talk about this example, guys, and we can consider here the value of k is 2. Let's see what will happen here. Okay, in this case, because we might need to remove 0 from our output, or we might need to include 0, because there are two scenarios, guys. In some scenarios we might need to remove 0 from our answer, or in some scenario we might need to include 0 in our answer. So that's what I am showing you this edge case as well. Okay, so let's talk about this. In this case, do we need to include 0 or not? Let's see. Correct. So first we'll insert 1, which is our top element. Correct, guys? So one would be in the top. Then we have 2. Again, we have to check our stack top is greater. No, stack top is smaller. So we'll insert it. Insert the 2 here. Correct. So it will look like this: 1. Then we are going for 2. Then we have a 0, something like that. 0, I'm drawing it. And then we have 4. And then we somehow here have 3. This is how our graph looks like. Now let's look for 0. Now let's look for 0. So guys, 0 is coming here, and you can see 0 is smaller than 2. It means it's a dip. It's a dip. So we need to remove 2 from here. Correct? So we will remove 2 from here, and we will reduce the value of k as well. The value of k will become 1. Correct? Again, we'll check. Is 0 is smaller than the stack top? Yes. Again, remove the 1 from there. 1 from there. And then make the kth value 0. Correct? Now in this scenario, guys, now you can see that because our k was 2, so we should not include this 0 in our stack answer. we should not include this 0 or stack answer, because the smaller element after removing 2 digits, it should be 43, not 043. Correct? So that's why this is the scenario when we do not need 0 in our answer. Correct? This is the first edge case. Did you understood why we do not want 0 in our answer? Everyone understood why we do not want 0 in our answer? So in this scenario, we will not insert our 0 in our answer, and we'll see how we'll do that. Yeah, I know that's what the question you are going to ask, how we handle 0. You can see here we are only inserting character in our stack when stack dot length is 0, greater than 0, when the stack dot length is greater than 0. So that's why where you can see in this scenario stack dot length has become 0. So that's where that particular character we will not insert in the stack. And the second scenario we have not discussed, but we will discuss second scenario as well. But first scenario, did you guys have understood? We'll just simply check if the stack length, if we do not have any in the stack, we will not insert that character. Understood, Parag, how we handle the 0 scenario? Correct? Now let's see. Okay. Now let's see if we need to insert 0, then what? In if we now let's see if in the any of the answer if we need to insert 0. Correct? So in that scenario, what will happen? Now let's see. Now let's see in the same example actually. Let's see in the same example. If we just want to delete one element, in the same example, if we just want to delete one element, the value of k is 1 here. So now let's do again. So first we'll insert 1. Correct. Then we'll insert 2 because it's not smaller. There is no dip. Now we got 0 here. Now we got 0 here. So what we'll do here? What we will do? Again, we'll remove the first element from here. Correct? We'll remove the first element from here and reduce the value of k to 0. And now guys, you can see we need to insert this 0 in our answer. We need to insert 0 in our answer. So what we'll do? Whatever remaining elements are coming, we'll directly insert them. 2043. Sorry, not 2. 2 we have already removed it. Not 2. 1043. And our answer will look like 1043. That would be the minimum which we can do here. And that same thing we are following here. If stack dot length is greater than 0, then insert it. And second condition, if character is not equal to 0. So see, this is OR condition, right? This is the OR condition. So if stack dot length is greater than 0, we will insert it. We'll insert it. So you can see in this scenario, the when we are trying to insert 0, at that time stack dot length was 1 because we already have the 1 there. So in those scenarios, this particular condition will take care of both edge cases, when we need to include 0 or when we do not need to include 0. Okay, because this is not end. If end happen, then we will not be able to insert it, but this is OR, so it will take care of that. And this is the first edge case where we have like 1 2 3 4 5. Correct? 1 2 3 4 5. You can see in that case I told you reduce the value of k and pop it. And you can see guys, our condition also stack dot length kth value should be positive, and every time we should check stack top. If stack top is greater than our current number, do the stack pop, reduce the k minus minus. Whatever we are doing, it's written here, and all the edge cases are also there. Correct, guys? And at the end, in some scenario, after doing everything, we do not find anything in the stack. At that scenario, just return 0. There might be some scenarios like the value of k is 5. Everything we have removed from the stack. Right, guys? So in those scenarios, we will return 0. And then at the end, whatever in the stack, just join it. I hope you guys have understood all the edge cases, also the code, everything. Are we good here? And somebody has, and okay, Suraj wants to talk. Okay, let me see that. Yes, Suraj.
हेलो सर।
यस यस, पता है।
हाँ सर, सर आपने कहा स्टैक तो लेंथ ग्रेटर देन जीरो का सम पुश करेंगे, तो सर फर्स्ट वैल्यू कैसे पुश होगा सर स्टैक के अंदर?
फर्स्ट वैल्यू इस तरीके, सेकंड कंडीशन से, व्हेन सी एस इज नॉट इक्वल टू जीरो, सेकंड कंडीशन से। सेकंड कंडीशन में तो तुम्हारा करेक्टर जीरो नहीं है ना, ये कंडीशन
ओके
ट्रू हो
सर।
जाएगी और वो हमारे स्टैक में पुश कर देगा।
हाँ सर, हाँ, राइट राइट, ओके
करेक्ट।
सर। यस सर।
आई होप एवरीवन अंडरस्टूड। Guys, are we good with this question? I know we have already done it earlier, but today we revised it. Didn't we reverse, sir? No, actually, we do not need. See, in our stack, it will look like this: 1, comma 0, comma 4, comma 3. Because the stack is our array. So in our array, it will look like 1043. So we'll just join it 1043. Answer will be like this. We do not need to reverse it. Okay, Ariran? Yeah. Because in the stack, the first element go to the 0th index. It's an array, right? So we'll simply do that. Are we good with this question? Can we move into the next one, guys? I think this one we already done it, so that's why you guys have quickly understood this question. But still, if anyone has any doubt in the code or anywhere, let me know. Why to go without thinking, without like, why to go to next question when you guys stuck somewhere here? But that's why I'm just giving you a chance to just see it one more time and tell me if you guys have any questions here. No doubt. Okay, great. So now let's jump into the next question then. Okay. Okay. Thank you. So yeah. So next question is also very easy question, guys. Very easy. I think I will ask you guys to tell me the solution. But yeah, before that, let's read the question. So for a school parade, boy and girls have form a line. They have to form a line. Boy is represented as B and girl is represented as G. The order in which they were supposed to stand. Now the question is here. The order in which they are supposed to stand was that the girls should stand at one end of the line while boys should stand at the other end of the line. So like this will look like this. If there is one line like this, then boys should be all the boys, like I'm just representing them as a B. Why draw this? I have bad right drawing. So all the boys should be standing at one end and all the girls should be standing at one end. It's not like that girls has to be in the end. They can be at the first as well. And it's anywhere they can be. If you are considering this as a first, they're standing at the first, and boys can also be here. But yes, that's what they need to follow. All the girls at the one end and all the boys should be at the one end. That's what they need to follow. Okay. Now you can see that that's what they're saying. While boys on the other end. But what happened? Few student has broke the order by standing anywhere in the line. Now your job is to help the teacher to identify minimum number of such students who are violating the order and remove them from the line so that post their removal the order is maintained. So there are some boys who does not follow the rules. They are just standing in anywhere in the line like this. Let's consider the third example. Some boys are standing here. Again, I'm just taking it like that. No, no, no. 1 minute, guys. So some boys, and then one boy is standing between the girls, like that, or two boys we can consider, right? They're standing between the girls. So what need? So they are violating the condition because all the boys should be at the one end, correct? There should not be any boys between girls. So that's what we need to help the teacher to find out those boys who are violating the rule here and then remove them from the string or from the line. That's what the question is saying. So I think in this question we need to remove these two suspicious boys. These two boys, we need to remove them from the line, and after removing them our answer or our line will look like this. Correct, guys? So that's what they're asking about. The count is equal to 2. So they're asking about, you have to tell the minimum number of element. You can see the output is 2. Let me read the comment. I think you guys have some funny comment or what? Like me. So is saying like me. He's that boy. Girl is also standing between boy. Yeah, we can say that as well. Girl is also standing between the boy. So we can, but yeah, they have to stand it at one position. They have to stand it on one side. Girl has to stand at one side and boys has to stand at one side. Okay, it's not. I am just taking the example of they are girls. You can take the other perspective also, as the saying it. Girls can also be standing in the between of boys. What's the count? So the count is Joseph here. The boys which we need to remove from the line, which are violating the rule. So those would be 2 boys which we need to remove from the count. Okay. Okay, guys. So that's the problem. Okay. So guys, you can see that now. Just think about solving this problem with the help of a stack. Now let's think about solving this problem with the help of a stack. So now, if any idea which is coming into your mind, what we should do, because we know that after a girl, only girls should stand. After a girl, only girls should stand. Or we can say, after a boy, only a boy should stand. Correct? I think, yeah, that would be great. After a boy, only boys should stand. Not any girls should stand. I think, yes, if we take that assumption, I think you can get the answer. If anywhere you find that after a boy, a girl is standing, you need to remove that boy. Correct? After a boy, if you find out anywhere a girl is standing, you need to remove that boy. I think that's your solution. What do you guys say? Correct? After a boy, if you found any girl is standing, then you need to remove that boy and add it into the count. Correct? So, okay, so it has given the answer. So while stack.peak is not equal to student I, stack pop. Yeah, similar to that. But yeah. So see guys, from where we should start our loop? Should we start from the 0th index or should we start from the back? We should, I think we should, you guys tell me from which side? Yes, from the back. That's right. We have to start our loop from the back side. So let's do that. Let's take the same question here. This one is our question, right? We do not know which boy is causing the problem, right? So we'll take our counter as a 0. The starting, take our counter as a 0. And let's erase the final answer as well. This one. Okay. And let's take the stack here. And let's start from the back side. Let's start from the back side. So first, this girl is coming. Okay. Right now, stack is empty. Insert it. Okay. I'm fine. This girl is done. Right. Now let's go for the next girl or the next element. Right. Now let's go for the next girl. So guys, before going into that, just check into your stack top or stack peak. So right now, if the stack peak is girl and the current element is girl, then no problem is there, right? You can simply insert it because the two girls can stand in the line, right? Adjacent to each other. So you can simply insert this girl as well. Correct. So this girl has also been inserted. Now a boy is coming. Correct. After a girl, boy can come. After a girl, a boy can stand there. But after a boy, girl cannot stand, right? That was our condition. That's what our condition, correct, guys? After a girl, a boy can stand. But after a boy, girl cannot stand. Correct? So that's what after a girl, now boy is coming. So we can simply push it. We can simply push it because after a girl, boy can stand. So you can see boy is standing there. But now after this, we'll see. After this, now this girl is coming. Correct? Now this girl is coming. So what now your condition will fail. That after a boy, a girl cannot stand. So you will check stack peak. If stack peak is boy and current element is girl, you will pop it. You will pop it. You will pop all the elements till that condition happen, because there could be multiple boys are standing, right? Like this, see, this will be a while loop because there could be multiple boys which are standing. So that in those scenario, you have to remove all the boys till you got a girl scenario. Till you got a girl scenario. Correct? So what you will do here? You will first remove this boy. Let me correct the first input. Yeah. You will remove this boy and increase your count to 1, because you have removed one boy. Correct? Now let's go for the next girl or next element, which would be this, which would be this. Again, you will check with the stack peak. Yeah, it's a girl, simply push it. Simply push it. Again, go for here, girl, push it. Girl, boy, it's fine. Push the boy again. Now let's go for again girl. So this is not possible. After a boy, we can't stand a girl there. So that's why we'll again delete this boy. We'll again delete this boy from here. Right, guys? And we'll increase our count to 2. Right? Then we'll traverse the next element, which is the boy. So boy will be inserted, again boy, and again boy. So the final answer would be 2 here. Correct, correct, guys? Yes, that same example. Correct, Ekta. You got it correctly. Push that G. That doesn't matter actually. That doesn't matter, Joseph. You want to push that girl or not, that doesn't matter. Okay. After a boy, a girl can't come. But you can push it or not, it still doesn't matter. Yeah. You want to push it, you can push that girl. That's fine. Okay, guys. That's been the last point. Last point. The last point you mean, I didn't, I forget what is the last point actually. What's the last point you were mentioning about? Is it, because there is only one condition. After a boy, girl can't come, right? Yes, after a boy, girl can't come. Right, that's right. That's right. You can see, after a boy, girl cannot come. So that would be your condition. You will be checking if the stack top is a boy and current element is girl, you will be going for pop operations. You will be going for the pop operations, and you will continuously do that till you see the same pattern. Till you see stack top is boy and current element is girl. Till you see this situation, you will continuously pop it. Continuously pop that element from the stack. And you will increase your count value. You will increase your count variable. Okay? Let me show you the code also now. Code is easy, right? Let me show you still. Yeah. So guys, you see, we are first iterating our stack or our string from the back side. You can see as dot length -1 till the 0th index. Correct? If and I'm taking my res as a stack. This is stack. I'm first checking stack dot length is 0. Yes. Insert that character. Insert that character in our stack. Correct? Then we are checking the same condition. If the stack top is boy and current element is girl, then increase the count and pop it. Increase the count and pop it. And then if that's not the scenario, simply push all the element. Simply push all the element. And then you can see at the end we are returning a count. Okay, guys? That's what we are doing there. Easy code, right? We are just checking that the stack top should not be there. So we are using if on the line 21, not while loop. 1 minute. On the line 21, okay, this thing. Correct. So let's see that with the while loop it will help us or not. Let me see. Let me see, guys. So B B B G, and then we can say B B and G G G. Okay. Let's see with the while loop it will help or we need to fix this code. 1 minute. Let me check this solution, guys, with this example. Okay. Let's see. So we have inserted first girl here. Okay. Then because we have again check the next index, which is this. It's again girl, girl. Okay. Simply push it. Then we were going for this girl. Okay. Push it. Then we are going for boy. Push it. Okay. And then we have seen another boy. That this will push it. Now we've seen the girl here. Correct. So now we need to delete this boy. Correct. So when we'll delete this boy, so it will be 1 here. Correct. And we are not inserting this G. So this would be the scenario. And then boy, boy, boy. Okay. See guys, this is also fine. We have deleted that girl from here now. Correct. We have deleted that girl from the stack. So I think yes, without while loop, it will still help us. We are not inserting that girl now in the stack. Correct. Otherwise, if we simply, I think the what I told you here, it's just that we are only going to delete boys totally, but that's not the case here. We can also delete that girl, right? Because after boys has started coming, this girl is coming into the middle. So we have deleted that girl. Let's take some more example. Let's see. Let's take some more example to understand this question. Yeah. So let's see. Yeah, B, girl, girl, boy, girl, girl. Okay, let's take this example. Here we might need to delete boys as well as girls. So let's see what will happen here. Because we need to make them in a one row, right? So let's see guys here with this example. Okay, let's see. So first we inserted girl, correct? Then we again inserted this girl, second one. Then we find out the boys, okay. According to line, now all boys should come, right? But boys is not coming. So now let's go for girl now. We can see that the same problem is there. So we need to delete this boy. We have deleted this boy. Correct? And we have increased our count to 1. Count to 1. And we have not inserted this girl. See guys, they are not inserting that girl as well. So this girl will not be inserted. Okay, now let's look for this index. So now we are inserting this girl again. Okay, now let's see boys, boys, and now girl is coming. Now girl is again coming. So after a boy, girl cannot come. So this boy will also be deleted. Correct? And then this girl can. So how many count we have done till now? We've still done 2 counts. Correct? We've still done 2 counts. And then we are not inserting this girl again. And then boy, boy. See guys, this would be our final answer. So I think in one way, we are not inserting 2 entries into our stack, which is the same girl where we have find it out. And again, the same girl we are not inserting. See, we're not inserting the girl also, you see, instead of code. We're not inserting that girl also. We are just removing it. I was thinking it should be while, but this one is also giving us the answer. Yes, answer should be 3. Let's see, guys, with this, what would be your answer? Let me see this one. Let me see, guys, 1 minute. According to code, what would be the answer for this? I think for answer it would be 2. B, B, G. Let me check quickly. Triple B. No. Double BG. 1 minute, guys. Huh? Let's check the answer for this. according to code. Double BG. Then we have double B. Double G is there. Okay. Then BGG. Okay. Let's see the answer for this according to code. Stack. Arrange is okay. Stack. Arrange student. Yeah, answer is coming as a 2 according to the condition. But let's read the question again. Are you missing anything? The order in which they are supposed to stand was that girls should stand at one end of line while boys on the other end, right? But few students have broken this order by standing anywhere in the line. Now your job is to help to teacher to identify minimum number of such students who are violating the order and remove them from the line uh, so that post their removal and order is maintained. On removing the boys as position 3 and 6, the order will be BBZZZ. Correct. Hence the count of student removed will be 2. I need to check this thing, I think, guys. Let me check if we have a similar question in lead code. So we can see the examples from there. They have only given one example, but let's see if we have more examples for that. Okay, so rearrange student. Yeah. Let's see if this is the question which we are looking here. And problem in stack. Yeah. See if we find out that problem. Book allocation. No, no, no. See, we do not have the more examples. That's why we are not right now sure about it. So let me check, guys, the more examples for it, and then I think we can talk about it again. Yeah, I believe there should be while loop. Yes, I also believe that there should be a while loop. We have assumed that the boys to be standing from left and girls from right. Okay. And why is that, Vishal? If we are standing boys from the right and girls from there, then I think our condition will only change, right? The question will still be same. The question where we are stuck right now, where here we need to remove minimum number of students, I guess. Yes, minimum number of students, yes. So, but I think still we should get 4, right? The student, not the girl or boy. Yeah, still, guys, we have removed 4 students, right? If I am talking about the student here, you can see in this example, we are not, we are like removing this boy, this girl, this boy, and this girl. We're removing 4 students. You can see in our stack, our output is look like 7 only. 1, 2, 3, 4, 5, 6, 7. And total number of there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So I think our output should be 4, right? We have removed 4 students from the line. If not, and if we are not talking about the girl and boy also, still our output should be 4. So that's why actually I just got confused here. So somebody wants to speak. So I think let's see. So Ekta wants to speak. Okay, let's see. Yeah, Ekta.
Hello. Sir, can you show that your notes again?
Sure. Mm-hmm.
Yes, sir. So the one written in black. So
Mm-hmm.
if you start moving from the end, so
Mm-hmm.
there are two girls, then a boy comes. So a boy can come after a girl, right?
Mm-hmm.
So yeah. So we'll first remove this boy,
Mm-hmm.
and then we'll continuously go on adding a girl, girl, boy, boy, and then after a boy, a girl is coming. So that that is invalidating our condition. So we'll remove this boy, the fourth one from start, this boy.
This one.
Yeah. Or so yes, so then we'll have to remove the boy before that as well, right? Because
Correct.
after a boy, girl cannot come.
Correct.
So then we'll have two girls continuously. Then
Mhm.
have two more boys. So I think so three should be the answer. Like if we are considering like that.
Hmm. That's what actually I need to check some more examples here. Then I think we can come into the conclusion.
So
Mhm.
yes, sir. So but for what condition? Like did you mention that we should get an answer as four?
So
If
I was
like
saying about, because you can see when we were removing the boy from here, according to code, we were not inserting that girl also in the stack. Correct?
yes,
You
sir.
can see in the code, when we are removing something, in that place, we are not pushing anything in the stack. So it means,
Oh yes, yes.
B has been removed, girl has been also removed. Then again B has been removed, girl
Oh.
has been removed. So it should be four students has been removed, right?
Okay, okay, sir. So, like from the code, we are not inserting. We are only popping and inserting if the condition holds true.
Correct. It's also.
Oh,
So
okay,
that's
okay,
what
sir.
actually I need to
Yes.
check with some more examples here. Then actually we can fix this code. Till now, because I didn't find this question anywhere else. They were just giving one example, so that's why I'm not so sure about it. Okay.
Yes, sir. Right.
So let
Thank
me
you.
just look into this one more, and then we will come back into this one. Yeah. Let me look some more examples if I get anywhere, and I will also mention this to the reliable team as well. That see, recently I found that uh, some of the answers I'm not getting back from the reliable team. So let's see, this will happen. So okay, so one would remove girls. So let's see the other scenarios also. Vishal is saying, let's talk about the remove girls as well. Let's talk about that scenario. Yeah, one would remove girl and the other one the boys. Okay, let's see one more scenario in this, guys. If we are starting from the this side, starting from the left side, correct? So let's take this example. Again, this example. Correct. Same example. And now this time we are going to traverse from the left side. And our condition now should be, and after a boy, girl should not come. After a boy, 1 minute. Uh, yeah, after a girl, boy should not come. Correct. That should be our condition. If on stack top is a girl, then next boy should not come. If that's the case, we need to remove that girl. Correct, guys? Or remove that student. Yeah, remove that student. So let's take about that example. So see, first we insert first boy, second boy, they're fine. Next girl is coming, that's fine. After the girl, boy is coming. So we'll remove this girl. We'll remove this girl. So count has become one. Count has become one. I think come into the same scenario here as well. And then and this time I'm inserting boy. Okay, I'm inserting boy here. So this boy has also been inserted here. Then this boy, okay. Then girl is coming, then it's fine. Then girl is coming, that's fine. And then this boy is coming, is fine. Because after a girl, after a girl, boy cannot come. Yes. After a girl, boy cannot come. So we need to do popping here. So we need to do this time pop what? We need to delete this boy, not the girl. Correct? So we should not insert it this time. Okay, now it is coming into the previous scenario. We should not insert the new element while we are popping it out. Correct, correct, correct. So yes, I think we will be again going back to the same loop where we have started. So I think let me see some more examples, and then we'll come back into to understand the answers here. Please use two pointers. Two pointers. Okay, let's see. Let's see if we are going to use a two pointers. So let's see from here, and if we have the second pointer here, right? Because okay, so boy girl is fine. So our condition should be here. From this pointer, every time girl we should meet the girl, and from this pointer, every time we should meet the boy. We just have to consider from one side boys are standing, okay? And then we can say wherever from this pointer, see, just first take the ideal scenario when we have this scenario, correct? So we have the pointer here, we have the pointer here, correct? And if they are meeting, um, hmm, and if we got like this is the girl pointer, this is a boy pointer. So once the girl pointer has passed the boy's pointer, like the girl's pointer index is greater than the boy's pointer index, we will stop our loop. Correct? We will stop our loop there. This should be our condition for stopping our loop. Right? Now what we need to do? This is the first condition. Now second condition. Wherever from the girl pointer we find out any boy, we just need to remove it. So let's see. If we are at this position, we need to remove this boy. Okay. At the same time, we'll get this girl, so we'll remove this one as well. Again, next is boy, next is boy. This girl is there, and then there will be yes. I think yes. With 2 pointers, correct. With 2 pointers, we are getting the correct answer. Yes, yes. That Vishal is right. So let's see how can we use the same thing with the stack. Did you guys understood with the 2 pointers? We were able to understand that we need to remove 2 elements only, or 2 students from the string to get the final answer which they were asking. Guys, you understood with the 2 pointers? Yeah, 2 pointers repeat. Okay. See, Joseph, what we did in the 2 pointers. Just first see the scenario where we are not seeing any issues. It means all the boys are at the one line and all the girls are at the same other line. So it means we will start 2 pointers, one from the left and one from the right side. Okay. Every time into the right side pointer, you need to check. It should always get a girl there. If there is no girl, we will just increase the count. Correct? So first, and they have to like start at the same point. So first, left will start from 0 and right will start from 5. Correct? We'll do left plus plus and right minus minus. And our condition would be when your right index is is yeah, if your right index is smaller than left index, we have to stop here. We have to stop here. So let's start traversing. And here inside you will check if your right index is not equal to a girl, you will increase the count plus plus. And I think same goes for the left index as well. If your left index is not equal to boy, you just need to increase the same count plus plus. We can keep the same both condition in one condition only while putting the or. So now you guys check. So we'll start from the left. We'll do the left plus plus. So first we'll check left 0, right 0. They are fulfilling condition. Nothing to add in count. Let's go from here. Now left is here, right as here. They will again follow the condition. No need to add something here. Left will be 0, 1, 2. So left would be 2, right? And here the right would be, I think 0, 1, 2, 3 or 5, 4, 3. Right would be 3. Correct. Next time when you will check this, now your left will become 3 and right will become 2. Now left will become 3 and now this condition will fail. So you do not need to delete anything from the count. You do not need to delete anything for this string. Correct. So that's why your count will be 0 and you will return that. You do not need to delete anything from there. But just apply the same logic here as well. You will see that we will start from this boy, start from this girl. Correct. Once we reach to this girl and our this pointer will become reach here, we need to increase our count 2 times because we need to delete these indexes values because we got girl in the left side or in the boy side. So we have to delete this one. Same for this one. And again, the same goes there. Here left index, here right index will become greater or smaller than the left index. We'll stop the loop and our answer will be count is equal to 2. Correct? It should be Ri greater than Li. Ri greater than Li. Ri greater than Li. No, Ri is already greater than Li. Oh, okay, okay. Ah, for this thing. Acha, acha. Okay, okay. Yeah, yeah. That's right. That's right. That's right. That's right. Ri greater than Li. That's totally right. Yeah, that's totally right. Yes. With that only, we will be inserting into the loop. Correct. Correct. Once your Ri become smaller than the left eye, then we will stop that value. Correct. Correct. Now you guys understood. With the 2 pointers, we are able to help it. But let me see. Please see my code is submitted. Oh, you submitted? Where? In the repo? Oh, you have submitted a doubt. Okay. Okay. Let me see the doubt which Hariharan has posted here. So response is there. He's moving from the back side. He's doing else if stack top is equal to V, stack a girl. While stack B and response is greater than 0, count plus plus. So what answer you are getting here? Was that? What answer you are getting here, Hariharan? 3. But we should be getting 2, right? We are only removing one boy and one girl. No? Are we removing 3 people from there? Oh, yes. 3 boys or 2 boys. Yeah, then it's fine. Then it's fine. Then it's fine, I think. So what are you doing? Let me check. So your stack top is boy and current element is girl. Okay, then you are going into this condition. Then you are checking till your stack top is boy and your stack is greater than 0. You are removing everything. You're removing all the boys from there. Okay, and then you are inserting the, definitely there would be a girl there, right? Then you're removing that girl also. Correct. Yeah, but I think, yeah, I have to check. Yes, yes, I understood. I understood. See, I cannot say this is the correct way or right, but yes, your code is working as we explained. It should be removed three versions. But I'm looking for more examples for this question. Then I think I can say that is it the correct one or not? Yeah, I'm looking for more examples. Question demand minimum number of students. Yes, question demand minimum number of students. Yes. So yeah, in that scenario, it should remove 2 only. Correct? See, Parag has raised the very nice point. He's saying question demands minimum number of students. In this one, if we want to remove 2 minimum students, it would be these 2 only, girl and boy. Then answer should be 2 here. So that's why, guys, let's see some more examples I will ask and then we will finalize. Otherwise, the 2 pointers approach is absolutely easy. And I think it is giving us the answer which we are looking here. So stack is somehow not able to help us here, but 2 pointer approach definitely helping us here. Okay. Okay, guys. So let's now look for the next question, which is interesting. The water trapping problem. Okay. So can we move into the next question, guys, now? Or do you guys still have any other like discussion want to do here? Yes, 2 pointer is easy. Yes, 2 pointer was easy. Correct. Let me connect the charger one minute, guys. Yeah. Oh, you want to go for break? Okay. So right now it's 11:18. So let's come back at what, 11:33? 15 minutes. Let's come back at 11:33. Okay, guys. So let's meet at 11:33. Is everyone back? What about others? Okay, so let's wait for 1 more minute. So the next question is water in storage, or sometimes we say that rain trapping problem. Rain trapping problem. Trapping rainwater. This is also very interesting question, guys. Rain trapping problem. Okay, so we'll wait for 1 more minute, people to come, then we'll start talking about this problem. Similar like the histogram and the rectangular one, max rectangular. This problem has been also asked in some of the interviews. So let's meanwhile read this problem. They're saying we will be given an array, non-negative integers, representing an elevation map where the width of each var is 1. Compute how much water it can trap after raining. You can see the blue one is all the waters there. The blue one is all the water, and this the black one, you can consider this as a buildings, correct? So you can see how much water it can consume. So you can see here 1 liter, because the width is 1. So 1, here you can see 1 more 4. So you can consider it's a 4, right? 4 units are there. So 4 unit, here 1 unit. So total 6 unit we can trap it between these walls. I can consider, or sections we can consider, whatever we want to say here. Correct. So that's what the 6 liter water we can store here. Okay, let me draw it a little bit better way. Now everyone is here, right? Or let's see what's the time right now. 11. Yeah, 2 minutes has passed. Okay, so now let's jump into the question. Okay, so now let's take the same array of same example here. 0 1 0. Let's take the same example. 0 1 0. What else? 2 1 2 comma 1. 0 comma 1 3 comma 2 comma 1 comma 2 comma 1. 0 comma 1 0 2 1 comma 0 1 3 2 1 2 1. Okay, guys, so similar like the histogram, as we started in histogram considering this value as a building height, let's do the same here as well. Okay, let's represent this in a building. So this would be a 0, which does not have anything. Okay, there is no height of building. Then we have 1. We can consider this as a 1. Correct. Then we again have 0 here. Sorry for bad drawing, guys, but yeah, that's all you have right now. Then we have 2 here. Then we have 1 here, right? And then we have 0 here. Correct. This one. Then we again have 1 here. Then we again have 3 here. Then we have 2 here. Then we have 1 here. Then we have 2 again. Correct. And then we have 1 here. Correct. So let me just write it somewhere, the values. So this is 0. This is I think 1. Yeah. This is 0. This is 1. This is 3. This is 2. 1. 2. 1. Correct. We have represented every elements in that array. With our height, we can consider this is a building. Okay, guys. Now you can think about some rain is happening. Rain is happening. These are the buildings, and all buildings are connected. You can see all buildings are connected. Correct. So now some rain is happening. So you can consider how much rainwater we will be storing it here. So where we can only store? We can store some water here. I'm just representing water like this. Here. Because if we store some water here, it will be going out of it. It will be going out of it. Same for here. You can see after this building, there is nothing to save the water. So this water will also go out. Same for here, out. But where we can store it, let's represent that with the black. Here, till here, we can store it. Now, if we go after this building, so we can store, I think, till here. Right, guys? We can store here as well. Then if we talk about here, we can store only at this place. Correct? Now, if the width of each building is one, if the width of each building is one, so let's count it out how much water we have stored. So let's see here. It's one, height is also one, and width is also one. So it's one. Let's see here at this index. Again, it's a one. Let's see here in this index. So I think width is one, and this one is also one. So 1 unit here as well. Same goes here as well. 1 unit. Correct. And remaining here. 5 is coming. Something is missing. Oh yeah, we missed the middle one. This one. Because this is also storing, right? We are storing here. See, this one, and this is also 1 liter. So yes, it's a 6. That's why 6 liter or 6 unit of water we are storing it here. Now you guys got the question? Yes? Now we got the question, guys. Everyone, we have to calculate the how much water we can trap it here. Okay, if you guys remember in the histogram question, what we were doing in the histogram questions, if we have something like this, in the histogram, if you remember, if we have 1 here, then we have 2 here, right? Then we again have, sorry, 3, this is 1, then we have 2 here, then we have like 1 again. So you guys remember in the histogram, what we were doing at each index, we were trying to expand that. We were trying to expand it. Like this one can go till what area? So that's what this one can go till the last one. Correct? This one can go here. And now the area would be like 1, 2, 3, 4. So for 1, area would be 4. This would be the maximum area. You can see for the 3, we can't expand it anywhere. For 2, we can expand only till here. Right? Still area would be 4. And for 1 also, area would be 4. That's what we were doing in the maximum histogram area. You guys remember in the histogram question, we were doing the same. We were trying to find out the next smaller place, and next is smaller at the previous side, and next is smaller at the right side, not greater. We are not trying to find the greater. We are trying to find the smaller one, because till there we can expand it. Till there we can expand it, not the greater one, right? So we were trying to find out, let's see, we were trying to find out that one only, right? The greater one. Let me think what we are trying to find out. So see, if we want to expand this building, so till where we can expand it? Till there we can expand it till we get the any lesser, correct? Till there we can expand till we get the lesser height building. So yes, on the right side we were trying to find out the lesser value, and same goes for the left side as well. Okay, Vishal? Now you're able to understand why we are talking about the lesser here? Yes? Okay, great. Everyone also understood why in the histogram we were looking for the less part from the both sides? Okay. But here, guys, that is not going to help you. If you are still able to find out the lesser values or greater values, still that one is not going to help you. But let's see, if you are in this index 1, if you are able to find out the lesser, which is 0, but so this will not tell you how much unit of water you are going to store it here. Correct? So let's see how can we understand this thing. How can we understand this thing? 1 minute, let me see. So guys, for this particular building, how much water it can store it depends on its neighbors buildings. Like whatever the maximum height, you can see this is the maximum height it can store. This is the maximum height it can store. So it definitely depends on the greater building or the greater height building it has on the next side. It depends on the greater side building which he has on the next side. Correct? And same goes for the left side as well. What is the greater size building it has? Correct? We can say that for this building. Correct, guys? For the green one, we can I'm talking about this one. For the green building, we can say we need to find out the left greater and right greater. Correct, guys? Yes. But by both. See, that will tell us which one is minimum. Which one is minimum? You can see between the next greater and the previous greater, which one is minimum? 2. Till there we can store the water. That's why we have to fetch the both. Which one is minimum in those two? If there are multiple buildings, which one is minimum? We can see if somehow if we do not know the left side building, how we will know that how much water we can store? Where we can store the water? Between two buildings, right? Why not? Why not? We do not need. We definitely need the previous and next. Otherwise, how can you understand how much water you can store? You can only store water between two walls. So you have to know the height, right? I think this, okay. If this is one building, this is another building. If you want to store water between that, you have to know the heights of these two, right? With both heights. If this height is 3, if this height is 2, you can only store the water till the height 2. Correct? Till the height 2. For that index, we're checking from left. Why stopping at the next greater? Checking from the left. Why stopping at the next? We go from either left or right to left. See, you guys have forget the histogram question or what? You guys forget the histogram question. For each index, what we do in the histogram question? We try to find out left greater, first left greater. Then for the same index, we try to find first right greater. Correct? We did that or not? For each index, we find out the left greater and right greater. Everyone? You guys remember that? So same thing I'm telling here. For each index, you need to find out the left building and right building. Then only you can understand. Then only you see, if you will not able to understand for the building 1, how will you understand how much water it can store? You have to know that the left and right building. You have to know the left and right building, right? Then only you can understand how much height is required. How much height, like with this building, is lying between what? This building is lying between what? It does not make any sense, guys. I think you guys are feeling difficulty to understand this thing. See, let's think something else, some other examples to explain this thing. Okay. So if this is the building 1, guys, right? And if we have some space here, like 0, 0, right? Again, second building, which is 0, 0, right? And then we have a greater building here. Then we have a little bit more greater building here. Now, if I want to understand from here, from this building, how much water I can store, so I need to go into my right side and check for the greater element or greater building. I need to go into the right side. I need to check for the greater index here. And then between those two, which are the minimum, I can only store till there. That's what I was trying to explain. Vishal, does it make any sense now? Why we are trying to look for the two buildings? And why the minimum of that will help you? See, this is not the answer. This is not the answer. I'm just telling you this could be one way, right? This could be one way. I'm not telling this is the answer, but that's what this could be the one way to find out how much water it can store. Correct, guys? But now I'm telling you how this is going to give you the problem. If you will try to find out the first greater or first greater at the left, first greater at the right, some people might be thinking that this could be their answer because they have done the histogram. In histogram, we were doing the first, we were also trying to do first minimum at the left, first minimum at the right, and then we were able to identify the answer. That's why I'm telling you this is not going to work here, because let me tell you why. But before that, you have to understand this. Means here the one ball will immerse. Means here the one ball will immerse. I didn't understand what this meaning. What do you understand? What you are trying to say here, Hariran? Underwater. Your second example, okay. So I'm saying here the water will be here. This is the place. This is the space which you have for storing of water. This is the space. That's what I'm saying. Yeah. See, why emerging? You just think about the little bit, like all the buildings or on your roof are connected. So now you have two walls. The water will store between that, right? If you have something in the middle, you cannot store the water here. You can't store the water in this place, right? You can't store. This is the building. You can only store on top of it, right? You can only store water on top of it. That's what. But guys, this is not the answer. We will not get the answer with finding first, first and next greater and first next greater on the right side or first previous greater on the left side. We will not get the answer. Why? You see it from the zeroth index. From the zeroth index. For zeroth index, you can see you are not. If you apply the same logic, you will see one here. You will see one here at this side. It means you can only store at this building. You can only store water. Let me draw this. Let me say draw the same example. If we have a zero here, like no building at all, and then we have building here, which is having the height of 1 1, and then we have a greater building like 3, the same example above. This is the 3, and then we have 2. So according to the logic, zero's first greater is 1. It means this one, and zero's right is this one. So it means only zero can store this much water. But is it true? Is it true? Zero cannot store only this much value. Zero can store this water as well till the height of this. Till the height of second building. Zero can store water till the height of second building. Correct? That's what I'm to tell you, that the first greater and next greater will not help you. That's why the first greater and next greater. See, I was trying to come to this conclusion, but you guys stuck before that. You guys stuck before that. But I think now it is clear, right? The first greater and first greater on the left side and first greater on the right side will not help us here. Now you guys are able to fetch this information, understand this point. See, this is my same point, right? This is the point. The first greater on the left side and first greater on the right side will not help us, because we have seen the zero scenario. For the zeroth index for this building which does not have any height, it means on the ground, if we apply the same logic, so the first greater would be 1, the next greater would be 1. If we do the difference of it, and plus 1 which will give us 1, which will give us a 1 unit of water. But that's not true. We are not storing only 1 unit. 1 unit is this one, then we are storing this unit as well and this unit as well. Correct? So we can only, I think, no, only 1 unit we are storing extra, because it's a 1 and 2 only, right? Yeah. So we are storing this unit as well. This is this unit and this unit. You can see we are storing 2 units, but according to our logic, it is giving us answer as a 1. Which is not correct. No, not for zero special case. This will happen for many things. This will happen with 1 as well. It's not like that. See, I was trying to tell you here, guys, that the first greater and next greater will not help you while solving this problem. I am trying to say this thing because you guys can easily relate this question, right? That's fine. That's fine, Vishal. That's fine. That's fine. That's fine. See, I'm trying. See why I'm telling you these things, because I'm not sure you guys remember about the histogram or not. I'm trying to first tell you the difference between histogram question and the rain trapping question. In the histogram question, you were easily able to find out first minimum element on the left, first minimum element on the right, and then you were doing the right minus left plus 1. You were getting the height there. That's what you were doing there, right? But that's what will not help you here. Yes, we need to go for any other method, and that there are two methods to solve this problem. One is through the stack, and second one is without stack. So first we are going to see with the without stack. Second solution we are going to see with the without stack. So guys, the second solution. Now first, before moving into that, did you guys understood why this question is not similar as histogram question, and the next greater or previous greater is not going to help us here? Everyone understood? Clear? Okay. Now let's come into the solution. Okay. Now let's see. Now let's see for the zero only. What will be the solution here? Let's start again from the 1. Let's define the solution for each index. Okay. Now let's define solution for each index. Okay. So see, guys, for storing a water, definitely we need 2 walls. Correct? Then only we can store the water. Everyone agree with that? For storing a water, we need 2 walls. Then only between that we can store the water. Correct? So now for zero, we see that these are the 2 walls. Correct? Definitely water will be stored here. But water will extra. See, I'm saying that you guys tell me why it will not happen. I'm saying that after the water will reach here, I'm saying that it will start failing it out. See, I'm saying once the water reached to the height of this building, these 2 buildings, I'm saying what will happen? You tell me what will happen then after this reaches to the height of 0. What will okay? Let me tell you. Let me tell you with this example. If we have building 1 here and building 1 here, and this is 0. So once the water reaches till here, what will happen now, guys? Once the water reaches here, what will happen now? Once it reaches to the 1, what will happen? Yes, it will overflow. And it will go out of the roof. These are the roofs, right? And this will go out of it. So it means we are not trapping this water. We can only trap this much water, right? The 1 unit. Am I right? Correct? Everyone agree with that? You guys are able to visualize it also? See, I'm also doing the visualization. Okay. Now, why it is not failing here? What is the case here? When we are going out of it? Why it is not going into this way? What's the reason? You guys tell me. Why? Once it reaches to the height of these two buildings like B and C, once it reaches to the height of B and C, and now you can consider D and I, these buildings are D and I. So why it is not going out? Why we are not saying that it should fall it out? Yes, because of G and I. They will trap the water. Okay. Now you guys tell me this water which they are trapping, till what height they will trap it? Till what height they will trap it? Till what height or till which building? Till which building they will trap it? Otherwise, it will start flowing out. G. Now you guys are able to visualize it. Yes. So that's what, guys. It will be filled till here. And then after that, whatever extra water will come, it will go out of it. It will go out of it. It will go out of it. Everyone able to understand, visualize this thing? Yes? Everyone? Anyone has any question till now? Yes? Okay. See guys, if you guys have observed this time, for any of the index, so for 0 also, it has to reach till 2. It has to reach till 2. So for 0, the height is 2 and distance or width, whatever you want to say, distance or width is 1. So we can say for 0, the total water it can conserve for this 0, it is going to be 2 multiplied by 1, which is 2 unit, which is going to be 2 unit, right? Let's look for the 1. What about the 1? First, yeah, before that, did you guys understood why the 2 is coming? For 0, did you now guys understood now why the 0 is coming? Everyone? That much unit water it can trap. Yes, that's right. Yes, right. Joseph has asked nice question. What will happen in that guy and that scenario, guys? Now he is asked one more question here. Let's see that also. Yeah, let's draw here. If we have one more building which is larger than this, 4. What will happen in that scenario, guys? Now, till what water will store? Till what water will be trapped? 3. Yes. Till I building. Correct. Now you can see the pattern now. Are you guys able to see the pattern now? So every time you have to reach to the, see guys, this time, every time for any of the index, this time you have to reach for the absolute greater. Absolute. See, earlier we were trying to look for the first greater, but no, in this case, in the rain trapping problem, you have to look for the absolute greater in both sides. Absolute greater. Absolute greater means the largest building which you have on the left side, because that building is going to tell you how much water you are going to store. And then between the left greater or right greater, whatever is the minimum, that is going to tell you the height. That is going to tell you the height. Now you guys can able to understand what is the value which is going to tell you the height. Next greater means not the first next greater, absolute next greater on the left side and absolute greater on the right side. The minimum of those two is going to help you. Let me write it also. So height would be minimum of absolute greater on left, comma, absolute greater on right. For 0. I will tell you for others as well, but first understand for 0. Correct? Everyone agree with this formula for calculating the height? This makes sense? You can visualize it? Everyone, anyone has any doubt? So absolute greater, not the first greater. That's why this question is different from the histogram. In histogram, we're looking for the first, but this time we need to look for absolute greater. It means whatever the greater value we have on the left side, whatever the greater value on the right side. Okay, guys? Everyone good? Everyone understood the height here? Okay, now let's look for, is it the correct height? Is it the correct formula for every index? Is it the correct formula for every index? Right now, I just showed you for 0, when the height of building is 0, is it going to true for every height, like every building? That's not true. Let me show you why. Let's look for 1. Let's look for 1. So see, for the 1, what is the next? What is the absolute greater on the left side? For 1, what is absolute greater on the left side? It's 4. So for 1, let's look for 1. For 1, left, it's 4. And right, what is right? What is right? What is the right greater? for 1. It's 3, right? This building. So the minimum of them would be 3. Minimum of them would be 3. So what it tells? It tells that it can store water till here. It can store water till here, right? Correct. But will it store 3 units? Will it store 3 units? Will it, when we are standing at the building 1, will it store 3 units? No, because of its own height. Because of its own height. Yes, we need to subtract that building height as well. We need to subtract that building height as well. So that's why this will be the 1 unit and this will be the 2nd unit. So every time the correct formula for calculating height is min absolute greater on left, absolute greater on right, minus current element height. Current element height. Bus, guys, you have just solved it. This is the formula. And for distance, now we'll talk about the distance as well. But yes, are you able to now got it? I think you do not need distance here, by the way. Distance will be 1 for every index. Distance will be 1 for every index. Now you can simply, if you use height and distance as a 1, you can calculate for each building what is the water it is going to store. You do not need the distance. Distance you can consider as 1. If you have understood the height, you can calculate now how much total water it is going to store. Let me show you. But yeah, before that, everyone understood the minus building height? Why we are doing minus building height? Everyone can understand why we are doing minus building height? Yeah? Anyone has any doubt? Let me know right now. Yes, it will not store inside the building on the, yeah, it will not store inside the building, yeah. Okay, now let's apply the same from here, from the 4th building, from the 4th. So I'm doing it here. Huh? Let's go for the 4. I'm taking the sum. This is the final water which will be saved here. So let's start from the 4. So for 4, what is on the left? What is on the left greater? There is nothing. So let's consider same value as if greater. For 4, there is nothing on the get. So just consider that as a greater. This is greater. On the right side, what is the greater value? On right side, there is nothing greater than that. So we'll take 4 as the same as a 4. Correct? Left and right, both are same for 4. Now, the minimum of this, minimum of 4, 4 minus 4 would be 0. So from here, you can easily visualize also whatever water will fall into this building, it will fall down. It will fall down. It will go into the ground, or it will go into this side. Correct? It will go into this side, or it will go into this side. That's why we can't store anything in the building on the top of building of 4. That's why we'll get 0. Everyone understood why we got the 0 for building 4? Visualization is also, and with the code also we got the 0. Now let's look for the 2. Now let's look for the 2. Left side we have 4, right side we have 3. So minimum of that 4, 3 minus 2. So minimum of that is 3 minus 2 is equal to 1. So 1 unit we can store it, and we can visualize it also. This is the 1 unit water we are storing it. So now we can add this into our sum. So 1 unit we have stored it. Okay. Now let's look for 1. So left is 4, right is 3. Left is 4, right is 3. Yes. Again, minimum will be 3 minus 1 is equal to 2. So 2 unit. You can store it here plus 2. Okay. Same goes for 0. Left is 4, right is equal to 3. So 3 minus 0 is equal to 3. So we'll store 3 here total. Now let's look for this one. For this one it will be same. 4, 3 minus 1, which will be 3 minus 1, 2. So again, one more 2. And for this 3, we can't store anything. You can see, yeah. So the left side is 4, right side itself 3. It's the greater one. So at that place, minimum would be 3. 3 minus 3, 0. So this would be our total answer. So we just add it. 8 units. Let's see. 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 unit, 7 unit, and 8 unit. Can you guys see that? That's how you solve it. Yes? That's how you solve it. So now, two things. We need to find out two arrays here. We need to find out two arrays here. If we take the same example here, the down 4, 2, 1, 0, 1, and 3. This is the building height, right? This is the height building. Correct, guys? Now, we have to find out two arrays, which is absolute greater on left, absolute greater on right. If we somehow can get these two arrays, we can simply calculate this thing, right? We can simply calculate this thing. If we have these two arrays, am I right, guys? If we have these two arrays, we can simply calculate the water or that formula min of left and right. Am I right or not, guys? For each index, if we can calculate what is the left greater and what is the right greater. So what we'll do? So for the first index, we'll take the same value, 4. Then for the next index, we'll compare it with the value in our array. Which one is greater? 4. Store it. Again, which one is greater? 4. 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 That would be for the left side. You can see everywhere it would be 4. Now let's look for 4. Let's look for right. Start from the right side. So first take the first value as same it is. Then which one is greater? 3. 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 Which one is greater? 4. Guys, with easy way you find it out, the next greater and the previous greater. Understood? Understood this part also? How we calculated the next greater array and the previous greater array? Everyone? Yes? Now it is easy, right? Now it is easy. We just need to calculate the final array, which is water, which will be minimum of these two minus this. So 4, 4 minus 4, 0. It will be 0. Which is the minimum? 3. 3 minus 2, 1. Which is the minimum? 3. 3 minus 1, 2. Which is the minimum? 3. 3 minus 0, 3. Which is the minimum? 3. 3 minus 1, 2. Which is the minimum? 3. 3 minus 3, 0. And at the end, just add this and you will get answer as 8. Guys, was it difficult? See how easily we have solved it. We just need to calculate two arrays and then apply the formula, this one, min of absolute greater on right, and then current element height. Guys, anyone facing problem? This is the first way. There is one more way which I'm going to tell you after this. So first let's complete this one. Are we good with this? See, I have not written the code for this. I have written the code for stack. So that's why I want to tell you the another way also, which is the stack way. But I want you guys to implement this code, which I have shown you the logic here. Can you guys implement it later and put it into the LinkedIn? Okay. But yes, if you guys have any queries into this, just quickly ask. So I can go into the next one, next way. Anyone has any queries, or we can move into the next one? Write in the chat. Next way, not the next question, next way. Can we go into the next one, guys? Move into the next way. Okay. Now let's see. There is one more way, which is through the stack, which looks a little bit complicated, but that's also easy, guys. Some observations, and then we can do that one also. Let me show you. Just take the same building again. This one, 4, 2, 1. Just take the same building again. 4. What is the next? 2. Then we have 1. Then we have 0. Then we have 1. Then we have 3. Okay. This is the 3. Okay, guys. So now let's think about if we have one stack. If we have one stack, this is 0. So guys, as you guys know that, like if we are starting from the building, if we're starting from the building 4, we see, we can only get to know, we can only what to tell, see, we can only understand that the water is going to store between the, when you see, when we are seeing a greater building, see how we were able to understand, how we were able to understand this time. Guys, do not see from the each index, this time do not see from the each index. I will tell you how to do that, but just see here, you can only get to know that your water is going to store when you have a greater element into the right side, when you can have a greater element into the right side. See, for 4, this is the 4 index, this is the building 4. You can't tell that this building is going to store water. You can only tell that when you have, when you will able to see any next greater building into this, when you will see any next greater building into this. Like see, if we have the 4 here, if we have seen the 5 into his right side, and then we have seen some onto his left side also, then we can say for 4 it can store some water, it can store some water, correct? Then only we can say that, right? When we have, when we were seeing the some greater building on the right side, some greater building on the left side, correct? Then only we can say it is going to store, the 4 is going to store some water, correct? So guys, from here we are also, we are first we will push all, first we will push starting our element, and we will push all the element till we see any element which is greater than our peak, which will see any element which is greater than our peak. Then we will start following the backside, then we will start going, see, for the 4, first we'll see the greater building on the right side. Once we find it out, greater building, then we will start calculating from the back side. So that's what we are going to do here also. So first we'll insert 4. Okay, because right now stack is empty, so we'll insert 4 here. Then we'll go for 2. Is it the greater than our the stack peak? No, so insert 2 here also. Let's go for 1. Is it greater than that? No, insert the 1 also. Let's look for 0. Is it greater than that? No, insert the 0 as well. Correct? Till now you understood, guys? 4, 2, 3, 1. Now we see the first greater building. Now we have seen the first greater building. So once we see the first greater building, now we need to follow some step. So for this building, see, you can write the indexes also. 0, 1, 2, 3, 4. By the way, we will not store the values in the stack. We will store the index. We will store the index. So see, this time here I'm storing the values. Here I'm storing the index. But in the real time, we will only store the index, not the values. Okay. So here 0, 1, 2, and 3. So we have covered the third three index and stored in the stack. Now for the fourth one, we have seen that we got the greater building compared to our current stack value. Correct? So now what we'll do, guys, here, first we will take the last element, because now once we find out the greater element, once we find out the greater element, we need to look for now the previous elements as well. So that's what we are going to do. See, now once we reach to this building, we are going to calculate the values for 4. So that's what we are going to calculate the height for this first, because we are going to store value here. So that's why we'll first fetch the last element, and for that we'll do the stack.pop. So once we'll do the stack.pop, we'll get the 0 from here. We'll get the 0 here. So now from the stack, we will remove the 0 and third index as well. Right? I'm just writing both things. value and index. So you guys can understand. Understood, guys? We have taken out the last element from the stack, which is our last element. Okay. Now we'll calculate two things, guys. So what we did, once we find it out, the greater building heights compared to our stack peak. So we have taken out that element or taken out that index. You can see in one place I'm showing you index, one place I'm showing you value. So I've taken out the index value from the stack. Now what I'm going to do, I'm going to calculate the distance and how much water it is going to store. Like the distance and height. We are going to calculate same height and distance. So for distance, your formula is this. Current index is what? Current index is 4. Current index minus, you can consider it as a current index. Let me write it correct. Current index. See guys, I'm still at the 4th building, right? I'm still at the 4th building. From there, I'm doing everything. So current index minus the previous index, this one. And from where we will get this index? We'll get it from the stack top. We'll get it from the stack top. So this is the index. Stack top index plus 1. So current index is 4 minus stack top index is 2 and plus 1. 1 minute. 4. 1 minute, guys. But let me check. The formula is correct or not? Oh, minus 1. Sorry, minus 1. Not the plus 1. Minus 1. Sorry, guys. Yeah. So now you can see we'll get the 1. And that's right. This is the distance. 4 minus 3, 1. I was just writing the plus 1. That's not correct. This is the minus 1. So this distance, first we'll calculate distance. Now we'll calculate the height. Oh, height is still same. Height is still same. So height, for that, what we'll do, we will try to find out the current element, the minimum of current element, which is 4, and stack top element, because we are checking between these two elements only, right? So current element height is 1, current element height is 1, and stack top element height is 1. Or minus last element, minus the last element, because you can see this is the last element, 0, the last element. So now you will see 1 minus 0 will give you 1. And now you have the water. 1 plus 1, 1 multiplied by 1, distance multiplied by height. So you will see in this place, you will going to have 1 unit of water. In this place, you are going to have 1 unit of water. Did you guys understood? Once we reach to this place, we try to find out how much water it is stored at the previous index. That's what we did. We calculated for the last element, not for this one, not for 1. We calculated everything for the previous index. And that's how we find it out. First, let me know, because these are the same step is going to apply everywhere. Understood, guys? Same step we are going to follow for remaining values as well. Okay. Now we'll again check. Now this is calculated. Now we'll again check. Is this one greater than the stack top? Because we have not inserted it. Is it the 1 is greater than that? No, it's not. You can see it's not. So what we'll do, we'll again do the same step. And this time, rather than last element is 0, this time last element would be 1. And then we'll start calculating it again, guys. So let me show you the code also. The similar code is working here, guys. You can see. While stack.length is not equal to 0, this is the first condition which we are checking here. That always the stack top element should be lesser than the current element. If it is not, then we are going inside the loop, and then we are simply checking the same thing which I told you. First we are checking the last element, then we are calculating the distance, then we are calculating the mean height, multiplying it and calculating the max unit. That's what the same thing is going to happen, guys. Same process is going to follow for the remaining buildings as well. Okay, guys. So see, guys, if you let me continue this thing. Let me continue this for remaining elements also. So till now, let me continue. No problem. Let me continue. So what we did. So yeah. So here we have 1. Here we have 2. We have calculated the values. So this time 2 is here, and right now we are at the 4th index. But yeah, before that, if I move it here, did you guys understood for 0 how we calculated it? For 0 how we calculated it? Did you guys understood now? Correct. Now we'll check. Now we'll again check the condition, because right now earlier it was 0 in the top, but now it's 1. So we are again checking, is this 1 greater than this? No, it's not. This 1 is not greater than this. So we will simply insert it. We'll simply insert 1 here and simply insert the index of it as well. 4 index. Correct? Because 1 and 1 is not greater. Correct, guys? We will insert that 1 also. Agree, guys? We'll insert that 1 as well. Now let's look for the next index, which is the 5th. Yeah, 5th index. I am right now here. Yes, this time it is greater. This time it is greater. So now what we need to do? Same step. Pop the last element, which is this. So stack.pop will give us the element as a 1, index as a 4, index as a 4. Correct? So let's find out the distance first. So current index, which is 5. Current index is 5. Stack top index. Stack top index, because this one has been deleted. This one has been deleted. So stack top index is 2. Is still 2 and minus 1. So it will give us 5 minus 2 minus 1 which will give us 2. So distance is 2. You can see for this distance is 2, because we are calculating from here, from this building. So this distance and this distance, 2 distance are coming. You can see this distance and this distance. So distance is 2. Guys, these 2 distance you can you guys can think these 2 distance. So distance is 2. Okay, now let's calculate the height. So minimum of current index height, which is 3. Minimum of current index height, which is 3. Let's write it 3. And minimum of stack top height. Minimum of stack top height. So in stack top, it's right now 2, which is so 3, 1. Right, guys? 3, 1, which will give us 1. And now 3, 1. So height would be 3. So minimum of this would be 1. Sorry, 1. Minimum of this would be 1. Correct? And the last element. So the last element is also one minute, guys. Let me check the formula for minimum. Let me check the formula for again minimum. See what we are doing. Height of is current stack and height of current. Yeah, we are doing correct. Okay, just the formulas are there, right, guys. So this is the height of current element, which is 3, and minimum height of current top stack, which is 1. So yes, so minimum is 1, and the last element is also 1. So 1 minus 1 is equal to 0. So for this particular index, it is giving us 0, guys. It is giving us 0. So we will not add anything from here. We will not add anything from here, because it might be we are going to calculate it with this index, might be, or might be from here. Yeah, I think from here we will calculate all the addition. No problem. From here, if it is coming 0, that's fine, guys. I think we will calculate everything from here, because we have this 2, 1, right? We have this 2, 1. That's fine. If the 0 is coming here, that's fine. That's fine. Let's keep it. Water is 0 for this height. For this height. Okay. Now let's go back again into our stack. Let's check. Stack is still 3, and you can see stack top is 1. We can't insert it. Again, do the same step. This time, take the 1, but index is 2. Rather than 2, 4, index is 2 this time. Correct? So now let's see. Current index is still 5. Stack top index is 1. Stack top index is 1. Okay, and -1. So now let's calculate the height this time. So distance, sorry. Let's calculate distance this time. So distance would be 3. Distance would be 3 this time. For this one, I am calculating, guys. Okay. Now let's calculate the height. So current index is 3, right? And for this one, yeah. So this element height is also 1 minute, guys. Am I calculating anything wrong? Stack top height. Stack top is, oh yeah, stack top is 2. Stack top is 2 right now. Yeah, stack top is 2 because yeah, stack top is this one, right? Stack top is 2 and current element is 3. Current element height is 3. So 2, 3, minimum is 2. Minimum is 2. Minimum is 2 minus last element, which is 1, which will give us 1, value as 1. And now if we multiply, we can see 3 unit it is going to store. What are these 3 units? 1 unit here, second unit this one, and third unit this one. That's why I told you for this one, earlier it was coming 0. That's fine. No need to think about it. Now you can see from this one, I calculated the 3. Now we'll go for the 2 also. Same, we will calculate 4 unit, I believe here. This will give us 4 unit. And then we will have the final answer. 4 unit, 3 unit, and 1 unit will give us the 8. This one is also easy, guys. The stack one is also easy. But it just, you need to remember some formulas. You need to do a little bit practice here. And you can see this one is actually easy than the previous one also. You can see in one while loop, we have calculated everything. First, we are checking whenever the height is greater, go inside that, pop the element, take the last element, and then calculate the distance, calculate the main height. I have written this one because this one was using stack. Earlier one was not using stack. Earlier one was simply using the for loop. So did you guys understood this question now? With the stack one, it's just the formula and every time you need to repeat it. What about others? Hariharan and Vishal says yes. What about others? Arad, Suraj, Joseph, Ekta. Did you guys have understood? Ekta says yes. So this code is already available in the repo. You guys can just look into this one and then let me know about it. Okay. Please repeat logic, lost network. So Joseph, which part you want me to explain? It's just the 3 steps which we need to follow every time. We need to take the last element from the stack and then we need to calculate distance. We need to calculate the height for that element. And for calculating distance, we are using the current element index minus stack top index plus and -1. That will give us the distance. And for height, we are trying to find out the stack top height and current element height, the minimum of that minus current element. Yeah, you can see the code. Yeah, it's there. Okay. Guys, can we move into the next question now? I think the next question, guys, you already aware of. Next question is the maximum rectangle one. So do you guys want me to explain the logic for that, or we can jump into the next one? The previous solution looks more convenient. Yeah, it's look easy. The previous solution looks easy, but second one is also easy actually. You just need to remember some of the things there. Okay. Okay, so rectangular one, I think we have done it in class as well, and we have one revision class for stack as well. There also we did it. Do you guys want me to explain the logic again for the max rectangular one? It was like you need to pass the first row, calculate the histogram for that, then add the two rows. Yes, maximum rectangle. Yes, the same question. The code is here. The maximum rectangle code. This one. Yeah. So first calculate the minimum area histogram from the left and right, and then finally add it. Wherever we are seeing 0 at the end, do not add that particular. Yes, remember the logic for that? The maximum rectangle. Yeah. If you guys all agrees, can we skip this one and jump into the last one? Or anyone wants me to explain the logic? Hariharan, Joseph, can we skip this one? Okay, Suraj, see, everyone agrees, then we can. Otherwise, we can go quickly see the logic. Okay, then it's fine. Nobody saying that. So let's jump into the next one also. So next one also, I think you guys have done it, but yes, it is little bit modified version. The next one, which is basic computator. Basic computator. So right, guys, you can see here, they will give you one expression and you need to calculate that expression with the help of a stack. So you can see here 212 multiply 6. They are writing like this. This one is also you done it, I remember, but this is little bit modified version of that. 212, then space, then multiply, then space, bracket. Then we have 65 plus 12, close bracket. Yeah. So if we simply solve this, as we know the BODMAS, so first the bracket will be solved, correct? So we will solve it. So it will be 7, 7. And then if we will multiply this, let me show you the multiplication of this. 212 multiply by 77. You can see 16324. And that's what our answer is. 16324. And when we have 123 divided by 0, we can say that can't divide by 0. Did you guys remember? We have solved a similar question. We have solved the similar question like this. Yes, correct. So what we did for solving this question, we will be taking two stack here. Two stack. One for number and second for, we can consider this as a symbols. Second for symbol. Correct? Until we have to somehow at the end clear our symbol stack, because we can't leave any symbols there, right? Is it like postfix? Yeah, that one postfix which we have solved. Correct. Similar to that, but little bit advanced version of that. Okay. But guys, just remember, just think about, we are going to keep all the symbols here. So symbols like this is one symbols. Asterisk, plus, minus, divide, open braces, curly braces. These are symbols. Okay. So we are going to store all these symbols in the symbol stack. So I'm saying at the end, symbol stack should be empty. Then we can only go for our answer. Correct or not? Symbol stack should be empty, right? Then only we can say we have executed everything. Like in this case, this will take asterisk, then this will take like curly braces, open curly braces, then it will take close curly braces. So somehow we need to remove all these things. And once our symbol become empty, then we can say whatever is stored in the number, we will take it. Okay, so now let's try to solve it. So let's start reading this string. Let us start reading this string. And just observe whatever I'm doing, because whatever I'm doing, I'm going to do the same thing in the code as well. So I will first take two arrays, one the number array, and second one is here for the symbol array. Okay, let's start traversing our string. So start traversing from 2. So it's the number. So we'll put it into which stack? In the number stack. Correct, guys? We'll put it into the number stack. But what does it make sense? So first insert 2, then insert 1, then insert 2. No, right? If you guys remember in the last postfix question, you guys remember we do something like this: 2, 1, and plus. Correct? 2, 1, plus. Then we pop it out this, and then we do 2 time pop, and then we run 2 plus 1. Correct? If you remember the postfix one, we are doing 2 times pop. So here, what we will do, we'll reduce that timing little bit. What we'll do here, guys, because see, once we will first put 2, then 1, then 2, then again we need to like 3 times do the popping. Better than that, what we'll do, we'll take a string, we'll take one like string variable, and till we are getting the numbers, we'll simply add into that. So first 2, then we'll traverse further. We'll go here into the 1. Then we'll add 1 here. Then we'll go further. Then we'll get 2 here. Then we'll go further. So once we reach there, so we see that it's not a number. It's not a number. So then just push this whole number to our number stack like this: 2, 1, 2. Because this number, now this whole number is going to be used. Wherever this number is going to use, it's going to be used as whole. Does it make sense to you guys? So the first condition is going to be, if we are seeing number continuously, just continuously add them as a string, and once we see any other character rather than number, we'll simply take that into the number stack. Are we good till now? Are we good till now, guys? Now quickly see the code of this part. Okay, just ignore everything else. So guys, see, we have taken 2 arrays, 2 stack, number stack and symbol stack. Just ignore everything else. Do not give focus to anything else. So we have taken 2 stack, number stack and symbol stack. Because that is coming as a string, so we have splitted our expression and make it a token array. Okay. Now we are just running a loop into the tokens like this. You can see we are just running a loop here. Correct? Yes, we have done it. Correct. And now you can see this is the first condition I'm checking, because you can see somewhere blank is also coming. So we will not add anywhere that blank. So that's why we are writing first condition as a continue. Otherwise, you can see the second condition. If the token I is greater than 0 or less than 9, create a string traverse till we are getting the 0 and 9. Traverse till we are getting 0 and 9. Till our token length is smaller than the I. Just add it into that string buffer, and at the end push that string buffer after making into integer, and then push it back. And then you can see I'm doing I minus minus. Why I'm doing I minus minus 1, guys? Because you can see in the here, you can see here I has reached to this place. I has reached to this place while operating this thing. So we have to come back. We have to do I minus minus. So I has reached here. So we have to do the I minus minus and read this asterisk again. Read this asterisk again. So that's why I hope you guys have understood this code till now. Here to here. Anyone has any question? Till line number 2 to 18. We have splitted our expression. We have taken 2 stack. We are traversing our tokens array. First, we are seeing variable space. We are not considering it. We are going for next index. And once we are seeing 0 and 9, we are entering into this if loop. We have taken one string. Then we are running one while loop. And that while loop is running till we are getting indexes between 0 and 9. And I value is greater than tokens length. Because if I value has become more than tokens, we have to stop it. And then once we fulfill these conditions, then we are pushing into the num stack. Are we good, guys? Till now, are we good? Because we are converting into the string. Converting it into the string. That's why we are putting 10 there. Just telling it the base. Parse and take a second one as a base. Okay? Are we good, guys? Everyone okay? Can we move into the next part now? Easy so far? Okay. Yeah. See, Arad. So we have just started our traversing our tokens array, and we are seeing it. If we are getting a blank, just continue. Go for the next index. If our index is going lying between 0 and 9, take a string variable, run our while loop till we are getting those conditions, like where 0 and 9 is there in the string. You can see we are doing I++ also every time. And then at the end, once we come out of this, we are putting that number into num stack and reducing our I. Line number 16. Line number 16. Yeah. So we are once we got our visualize it from here, right? Visualize it from here. Once you got this string as a 212 as a string, you need to convert it into this parse int and push it into the stack. So that's what is happening. We converted that string into the parse int, telling the base as a 10, pushing into the num stack. Got it now? See, I was thinking you might be asking about the I minus one, where it is happening, but you guys didn't ask this thing. But that's fine. I think you guys have understood why we are doing I minus here. Someone clear? Oh, that's nice. Oh, I already told that. Okay. Yeah. So now we will be again into the. So we will again read this element because we have done the I minus one. Going back. That's why. Yes, we are going back. You see, again, we'll come back to this for I loop and the I++ will happen. So now we'll again read the asterisk. And this time, because this is a symbol, we will insert into the symbol array. We'll insert into the symbol array. Because right now symbol stack is empty, so we'll simply insert it. Okay, guys? We'll simply insert it. Are we good? Okay, now let's read again. So now, whenever you are seeing an open bracket, whenever guys you are seeing an open bracket, you will simply insert it. You will not check anything. Whenever you are seeing this open bracket, you will simply insert it. You have to do some operations when you will see this character or a closing bracket, because you know once your bracket is closing, it means you have to do some operations. Correct, guys? When you are seeing any closing bracket, you have to do some operations, right? Okay, now you have seen this curly braces. Okay, that's fine. Now let's again look for this index. Now you are at this index 6. Again, same thing will happen. We'll create a string here 6. Then we'll go into the 5 and we'll stop here because now next is 6 plus. So we'll insert the 65 here. Okay. Now are we good? Are we good with the 65? Are we good with the 65, guys? Yes. Now, guys, once we are getting the, again, same symbol. I told you, right? For 2 times, you need to do operations. When you are seeing these symbols, asterisk, divide, and closing bracket. When you are seeing these symbols, you need to do some operations. But why we didn't do any operation for asterisk? Why we did not do any operations for asterisk? Because at that time symbol stack was empty. That's why we simply inserted that asterisk. But right now, plus is there. Right now, plus is there. Right now, we are inserting again the same symbol plus. There might be chances that we have to do some operations. We have to add something here. Correct, guys? There might be some chances we have to do the operations there. Correct. So before inserting plus here, guys, before inserting plus, we will check what is lying into the stack top right now. What is lying into the stack top? And if in the stack top, like in one way we can say we are checking precedence here. You know the BODMAS precedence. We are checking the precedence here, that uh, before inserting plus, just check what is in the stack top. If in the stack top, if you see like open bracket of closing bracket, you will simply you will not do anything here, because if you are seeing a open bracket, if you are seeing an open bracket here, it means there is a chances you might see a closing bracket, because when you see the closing bracket, only then you have to do the operations. Only you have to do the, after seeing the closing bracket, only you have to do the operations. You can see 65 plus 12 you will only add when you will see the closing bracket. Before that you won't add it. Correct. So this is the first condition you will check here in the precedence, that if you are if in the stack top, if in the symbol stack top you are seeing a open curly braces, you will not do any operation. You will simply push that icon, whatever it is here, even if it is a minus or multiply sign or divide sign, whatever is here. If you are seeing in a stack top or opening bracket, you will not do anything here. So what you will do, you will simply push a plus here. You will simply push a plus here. Okay. Now again, you will move your pointer to here. One will be here and 2. So now you will insert 2 as well. Correct. Now you will see the closing one. I told you in the closing one also you have to do the operation. So in the closing one, before inserting this closing one, what you will do, you will check whatever operation lying in here, whatever operation lying in here. If any operation is lying here, you will first do that operation. So you will first take, it's a plus. Okay. If it's a plus, you will simply take the 2 top elements from the stack and add them. So 65 plus 2 will become 77, and you will push them back into the stack. So this 65 plus 12 will be added and 77 will be added back there. And then you will remove this plus from here. You will remove this plus from there. Okay, you will remove that plus from there. Now again you will check. What is the next symbol is coming here. What is the next symbol is coming here in this stack. You will see it's an open bracket. It's an open bracket. What you will do, you will stop it here. You will stop that while loop here. You will stop that while loop here and remove this element from here. Remove that symbol from there, because you are executing the closing bracket. So first open bracket, wherever you got, you will simply remove that one, because you know that, right? For this closing bracket, you are solving the operation from the back, on the back side. So wherever you see the first open bracket, you will simply stop that while loop there and delete that open bracket. Okay, now that open bracket is deleted, there is nothing to traverse. There is nothing to traverse further. You will come out of loop, and again you will check, is my symbol stack is empty? No, asterisk is there. If my symbol stack is not empty, you just take that operation and take again the top 2 elements from the stack and multiply them with the operation, whatever operation is there, and again push the result back here. So your result will be pushed back here, whatever is the result was 16324, and then you will return this as an answer, and your symbol stack will become empty. These are the operations, guys, you need to do here. And let me show you the code also quickly for each operation. So see, guys, this was the operation when you are seeing 0,9. This is the first if condition. Second if condition, if you are seeing the open bracket, every time you are seeing the open bracket, simply push it. Simply push it into the stack. You can see, simply push it in the symbol stack. Correct, guys? Whenever we are seeing the open bracket, we are not doing any operations there. We are simply pushing into the symbol stack. Now let's look for when we are seeing plus, multiply, minus, and division, where there we need to do operations. But there are some conditions, only then we need to do the operations. We will see that. Like the precedence condition or open and curly braces conditions, those we will see into this else if. You can see in this else if will only come when your token is plus, minus, multiply, or divide. We'll go into the closing one. We'll go into the closing one in the last, but before that, let's enter into the plus, minus, multiply, and division. So what will happen here? So first we'll check system stack dot length should be greater than 0. It means if there are any element, if there are like you got plus, you got like if you have a scenario like this, if you have a scenario like this, 45 plus 32 plus 78. So first time, if you do not have anything, just simply push it. Just simply push it. You can see that's why in the code I am checking if the stack dot length is greater than 0. If stack dot length is not greater than 0, simply push it. You see, if the stack dot length is not greater than 0, simply push it. But if the stack dot length is greater than 0, it means let's consider this scenario. If we have a multiply, so we will simply push the multiply here. Correct? This is the first time. Correct, guys? This is the first time multiply symbol is coming. There is no bracket. This is the first time multiple symbol is coming. We'll simply push it. Now let's consider the second time it is coming. If this plus is coming, so now this will go into the while condition. This one. So system stack dot length greater than 0. Yes, it is. Now check the precedence. Now check the precedence. Which operations to do that? Which operations do that? Do we need to do plus or do we need to do any other operation? Because according to the BODMAS, we have to do first multiplication, not the plus. Correct, guys? We have to do the multiplication. So what we are going to do here, we are going to check. We are going to pass the multiply, like the current token, which is plus, and we will be passing system stack top element. And according to this, you can see that we will be passing plus comma multiply, because plus is our current element and stack top is multiply. Correct, guys? That's what we are going to pass. We are going to check the precedence. We are going to check the precedence here. So let's check our as precedence function. So what I did here, if I am checking if anywhere my operation 2 means if anywhere in my stack, operation 2 is stack, right? Stack element. If anywhere in my stack, if I have open or curly bracket, open and curly braces I do not need to do anything there. I do not need to do any operation there. I do not need to do any operation there. That's what you can see in the above scenario also. When we were having the curly braces scenarios, we do not need to do any operations. But in this scenario, we do not have operation 2 as a curly braces. We have a multiplication. So that's what we are going to check again. If operation 1 is equal to multiplication, operation 1 is equal to divide, and operation 2 is a plus and operation 2 is a minus, simply return false, because we can't allow it. We can't allow operation has to happen here. Right, guys? Because in our stack, we have plus here. We have plus here. So we can't allow it. But in this condition, because see guys, our condition is like this. This one. Plus multiply. So we can allow it because multiply has more precedence. That's why we are returning true here. That's why we are returning true. But if we consider the case of this multiply comma plus, we can't allow it. If on a stack, like just replace this question like this: 45 plus 32 multiply 78. So plus will be here, and then we will be passing the multiplies. At that scenario, we will be returning false. Here we will be returning true. Correct, guys? Understood? The precedence method, everyone understood? Plus multiply plus. Guys, understood? Now, so yes, so once we are returning true, you can see once we are returning true, we are simply doing the same thing. Take the operation from the a symbol stack, and take the two elements from the num stack and do the operation. In the operation, you can see if the operator is plus, add them. If the operator is minus, add them. So subtract them. If the operation is multiplication, multiply them. If the operation is divide, and if your n1 is 0, simply return can't divide by 0. Otherwise, do the division here. This is your compute operation. Okay. Then do the compute operation. So that's what, this is the condition for this. Now let's look for the closing bracket. If you got the closing bracket, so if you got the closing bracket, you just need to check till you find out the open bracket. You just pop it till you find out the open bracket. You just need to do all the operations which exist between them, and you are every time popping out all the elements, and from the symbol stack as well as from the number stack, and just doing the operations. And once you find out the opening bracket in your symbol stack, you will stop it there and remove the symbol stack. Okay, that's what guys is happening. And at the end, if your symbol stack is still not empty, you just do the same thing. Take the pop from the symbol stack, take two elements from the number stack, and push it back into the number stack. And that's what, guys. That's what happened total. You guys can. In which category it would come? It will come in, I think, medium. It would come in medium actually. Vishal, it's not difficult. There is no logic to think about. It just, you are seeing the BODMAS rule and implementing it. Simply like calculator, right? How you implement the calculator. In similar way, you are implementing this also. Just trying to think little bit extra. How to handle the brackets, which bracket should be solved. See, you just take a stack at the right side. Whatever is happening in stack, you just write the condition in that way. So I think it would come into the medium one. Okay, guys. So these are the 5 questions which we had in the stack, guys. So these, I think the rain trapping one was very nice question in all of them, and like which we have solved it. Otherwise, all the interesting question we have already solved earlier as well, like the removing k digits as well, and max rectangle we have already solved it. Compute expression, like it's time consuming, but yeah, if you will start writing the code easily, it can take, I think, 30 to 40 minutes if you are doing it first time. But yeah, all other questions were very nice. How do you guys feel it? Now stack is going to done totally. Now you guys need to just do the practice in stack problems. How do you guys feel it, guys? Okay, nice. Yes, please. You guys have to practice. See, you guys have done now 2 days, whole Saturday, then we have Sunday as well, and like half of Monday as well. So guys, just do the practice now from last class questions as well as this class question. Okay, and now after that, start solving questions from the lead code. Start from the easy stack problem and then go a little bit medium. Yeah. Okay, guys. So that's all from today. We'll talk soon. We'll talk on Monday. Okay. And in meanwhile, if you guys have any queries, any questions, just put it into the LinkedIn group which we had. So you guys, we can answer there as well. Okay, guys. Bye-bye. Have a nice weekend. Yeah. Thank you. Bye-bye.